Stratasys ASA printed on Stratasys 3D printer, Prusament ASA printed on Prusa printer. Industrial versus consumer ASA, huge difference in the price, but is there bigger difference in the strength? Let's find out together. Hello, welcome to my tech farm. A few weeks ago I compared the Stratasys versus Bambulab ABS, industrial versus consumer materials, and each are printed on their own printers. Stratasys ABS is also printed on Bambulab printer too, but anyway, I got several requests to do something similar but using the Prusa's best printer for this kind of materials, that's the Core One L. Now the problem is that the Prusament don't have ABS, they only have ASA. And since I don't have Stratasys 3D printer, I ordered some test objects from the Varinex company. I paid for these objects. This is not a sponsored video by any of these companies which I mentioned so far, but this is sponsored by Polymaker, actually not only this video, but the whole channel. It is good that it is sponsored because for these test objects I paid $94, and when I noticed that they are in a blue color, I have only black ASA here, so I ordered some Prusament ASA in Zephyr blue color too. Few words about these companies. Stratasys is a USA-Israel-based company, and they are making very good quality but expensive industrial 3D printers and filaments. Prusa Research, it is located in Europe, in Czech Republic, and they are very familiar in consumer printers. They are making one of the best consumer 3D printers on the market currently. Few words about the test objects. I got some pictures and footages, and from the slicer image I can see that it is printed with 100% infill as I requested, and it was printed on Fortus 450MC 3D printer, and the printing time was 8 hours and 40 minutes, and they use 0.178mm layer height. Interesting, the print temperature for the ASA was 235 degrees Celsius, but they also used the support, and for the support the nozzle temperature was 313 degrees Celsius, and also very interesting, very high chamber temperature, which was 85.5 degrees Celsius. The quality of this test object is great. There is no elephant foot and no shrinking. This should be 80mm. Properly it is compensated in the slicer, and even for this bridging they use the support material. But it's time to print the objects from the Prusament ASA. The bag is resealable. ASA Zephyr Blue. The nozzle temperature 260 degrees Celsius plus minus 10. But of course I will use the default settings in the Prusa slicer. I know not exactly the same color, but this is the closest I could buy, and still better than black or maybe even white versus blue. All objects are solid inside, printed with 2 walls and 100% infill with 0.2mm layer height, and the print temperature will be 260 on the nozzle, 110 on the bed, and 55 the chamber temperature. Filament is loaded and the top ventilation is automatically closed. Good start. So far perfectly straight objects. Printing is at 52%. And it will be completely fine. This printer handles great this ASA and similar filaments. The printing is finished. Quick bed adhesion check until it's hot. And looks like it is good. I have to wait until it cools down. It cooled down overnight. Yes. Well, actually the print quality is great in both cases. I really cannot see any difference between them. Maybe on the Stratasys it's a little bit smaller layer height, and that would be visible on near horizontal surfaces, but we don't have so many here. The only difference in quality I could notice with some ghosting on a daylight only, so it's a little bit better with the Stratasys compared to the Prusa. But I also noticed the dimensional accuracy is great too. I'm not sure is this shrinking smaller or maybe it is compensating in the slicer, so almost 80mm exactly as designed. So this is Prusament and this is Stratasys. I already measured some test objects, the weight is very similar. This is Prusament 36 and this is Stratasys 36 grams. So far these test objects are very similar, so there is no quality advantage of the Stratasys printing, but now it's time to start the mechanical testing. Hooks printed in vertical position. And now Stratasys 2 hooks. The brake was very similar in all 4 cases. These hooks are printed in vertical positions, so the layer adhesion is important here, and we can see small advantage on the side of the Stratasys ASA compared to the Prusament, but what I don't like here is this big difference. These two are much closer to each other, so if this Stratasys would be printed by me, I would print at least 3 more test objects for better accuracy. And now S hooks, these are printed in horizontal position. Side by side 2 materials. This time the brake was on a little bit different location. This test is less sensitive from the print settings and give us clearer picture of the material properties, and in this case the Prusament was much better. And now for more accurate measuring, I'm switching to my machines for the impact test, ISO and Sharpie, and here I can measure the bending and the tensile strength. 3-point bending test based on ISO 178, side by side 2 materials, and this footage is speed up 2 times. Here you can see the graph, and here the maximal force, bending strength and elastic modulus. The bending strength is calculated from the maximal load, so that's why only the bending strength is presented on the graph, because the ratio is the same, and we can see very small advantage on the side of the Prusament. Elastic modulus, it depends from the deformation too, and again the Prusament was just a little bit better compared to Stratasys, but the difference is not big in this case. Tensile test, these objects are printed in horizontal position. The maximal force, and the third one I forgot to create a picture, so this is from the history. And now Stratasys. And same thing here, the third one is recorded from the history. And again the Prusament was better compared to the Stratasys, but what I don't like here additionally is the standard deviation of the Stratasys testing. It is much bigger compared to the Prusament. Layer adhesion, vertically printed. The maximal force and the graph. And this is Stratasys. And again the maximal force in newtons. This is important property of any material, and here I converted the newtons into kilograms, and this is my table with the rating for these test objects, and we can see in both cases this is acceptable layer adhesion, but Stratasys is better even if it was printed on a much lower temperature. Impact resistance is important for these materials, and I'm starting with the Sharpie testing. Result from 3 measurings. Switching to the ISO hammer. Again our results, but let's see them on the graph. I think this property is important for ABS ASA materials because this is big advantage compared to any other filament type. And the Prusament, it has acceptable impact resistance, but Stratasys, this is very brittle, almost like some PLA or PTG. The creep test, deformation under constant load of 1.25 kilograms. An important property of ASA is UV resistance, and I'm doing this test outside. Locking the position for more accurate measuring. 1655. 1680. This is south side, and there is the sunrise. So on this location, they will be exposed to the sun whole day. This is day 2, almost 40 degrees Celsius outside, but I will measure them only at the evening. Quite a lot of deformation, but most of it happens in the first day for the ASA and ABS. 1769. 1780. But interesting, permanent deformation is smaller on the Stratasys. Blue is the initial deformation, distance between 2 reference surfaces, and with orange after almost 2 days. And we can see a little bit more deformation on the Stratasys test object, but the creeping in the percentage is almost equal. Additionally, after removed objects, a little bit more permanent deformation on the object printed from Prusament ASA. Temperature test in the oven. Objects are slightly tilted, so they will deform in the same direction. This oven thermometer is accurate, but it has a small delay. Prusament started to deform first, and then after 10 degrees, the Stratasys. So Stratasys performed much better in this important test. And now that elimination hook test, when the weakest falls out, but of course in this case I have only 2, so it will be only one pulling. Prusament Stratasys. This footage is slowed down 8 times, and we can clearly see the winner. And the winner is Prusament. Not really what I expected. Of course it's obvious that these two ASA filaments are quite different. We can see this even from the print settings. Here I collected a small table with the key differences in the print parameters, and I can see only 2.5 advantages of the Stratasys ASA over the Prusament. One, we still have a little bit better layer adhesion, even if it was printed at significantly lower temperatures. The second very important property for the ASA, that the Stratasys version is significantly more temperature resistant compared to the Prusament. Unfortunately, another important property for the ASA would be the impact resistance, and here the Stratasys ASA is very brittle, almost like some PETG. And that half advantage of the Stratasys version is that actually it is thanks to the printer, the quality is a little bit better. Actually, I could notice some additional ghosting on the Prusa printing compared to the Stratasys. The difference is not big, and all this is it worth that huge price difference, but this is something what you should decide yourself. Okay, so it looks like I will have one more similar video, Polymaker versus Stratasys with the PC ABS. And since the Polymaker don't have a printer, maybe I will print the test objects on both printers on Prusa Core One L and on a Bamboo Lab. It requires a high chamber temperature, and I already saw that the print temperatures will be significantly different, and I think maybe here the Stratasys may have a big advantage, but I hope you will follow me to that video too. Huge thanks to the Polymaker for sponsoring my channel, and to all my Patreon supporters, and to all you others. Well, thank you for watching this video to the end, and as always, happy printing!